Hello everyone and welcome to my class. In this video, we are now going to talk about symmetric patterns. First of all, as observed in the images below, notice that certain aspects of the image are produced identically when line symmetries are added to these figures. For instance, this first image has a one-line symmetry where both sides of the figure are identical or symmetrical. The second image contains a two-line symmetry where each of the um, figure between figures between them are also symmetrical as well. As for the third image, there's four line symmetry, one, two, three, four, where each and both side of between the line of the image are also identical too. Let me remind you once again what I mentioned in the previous video, where patterns have symmetry if there is an isometry of the plane that preserves the pattern. This means we are going to use the isometric transformations to produce more than one repeating figures that will be drawn on the plane, and thus creating patterns, just like these examples. But in this lesson, we are talking about symmetric patterns, which consist of three types: rosette patterns, freeze patterns, and wallpaper patterns. In the rosette patterns, these are patterns with rotation symmetry and, if possible, reflection symmetry. The reason why I said it is if possible because reflection symmetry is just an optional aspect for the rosette patterns, meaning that not all rosette patterns contain reflectional symmetry. As for the rotation symmetry, this is the fundamental unit that forms rosette patterns. So naturally, all rosette patterns contain rotation symmetry. And these are the example of rotational symmetry. As you can see, those lines here, those lines um, to provide you a more in-depth understanding of how rotational symmetry works, let's say that at one point, this actually stopped, this rotated at a certain axis and then goes on into a full clockwise, which means that some rotational symmetries contain some conditions where they will stop at one axis point and thus creating the motifs. And what I mean by motifs, like as it, those that are split into three or five figures are what you call motifs here, which are the basic units used to form and arrange a design and pattern. Now there are two types of rosette patterns, which are cyclic and dihedral. Remember when I mentioned about reflection symmetries, where, well, here is how it is used in the example. Well, but first let me tell you that in cyclic rosette pattern, this contain only rotational symmetry but no reflections symmetry. As for dihedral rosette patterns, this contain both reflectional symmetry and rotational symmetry. So in this case, as you can see, let's split them. Let's put some sort of division first. And in this case, let's say you put a line over here. And if you're going to if you're going to reflect this on this side, it reflects at the same time with in the other side. This what reflectional symmetry provides a division where both sides are actually identical to one another, except for this one though. This is considered a cyclic symmetry because if you're going to mirror this on the other side, it does not reflect at the same time. It does not reflect too as well. That's why it's considered cyclic and this is considered dihedral. Now, here in the freeze pattern, using translation symmetry as the main aspect, the freeze pattern generates repeated motifs in one direction. These are also combined with the other isometric symmetries, which are known as freeze groups. The first freeze group contains only one translation symmetries, which means that this actually from one point to another point in one direction, just only one symmetry. And here are the examples of what it looks like in art. The second freeze group contains translation and glide reflection symmetries, where they actually we're using translation to repeatedly move uh, from one point to a shift from one point to another in one direction, and glide symmetries added to it where, if you remember, it's a combination of translation and reflection. As for the third freeze group, this contains translation and vertical reflection symmetries. Um, Here in the vertical reflection where at this point this is considered a vertical reflection where this figure is, or should I say motif, is reversed into this one. And then after that, it will actually create another translate. This will be translated and form another, and will shift from one point to another point as well, and so on in one direction, which here you can see the example below. The fourth freeze group contains translation and rotation half-turn symmetries. Think of it as a small circle over here. And what I mean by half turn, which means not a full 360 degrees, but more like a 180 degrees. So you can say the foot just rotated right over here, which is the same case. And now it will be translated to one direction. As you can see, this is how the example, how this pattern works. The fifth freeze group contains translation, glide reflection, and rotation symmetry, rotation half-turn symmetries. As you can see, the glide reflection is where they actually jump from one side to another, meaning there's a mirror reflection line over here. And as for the rotation symmetries, they're actually how am I supposed to say this? They're actually, think of it as a small circle once again, where they actually switch over here and over there. The sixth freeze group contains translation and horizontal reflection symmetries. In this case, you when horizontal reflection indicates a reflection line over here, or a mirror line in between these two motifs, where this one had been reversed into become this one, and then will be translated over in one direction. And finally, the seventh freeze group contains translation, horizontal and vertical reflection. So it's a combination of horizontal and vertical reflection, which indicates that there's a, here over here, we first use horizontal to create two figures. And then after that, vertical reflection to create another figure, which is like this. And then will be translated to form repeated patterns in one direction. There may be more combinations I didn't mention, but at the very least, this is what freeze pattern is all about, where they actually repeated, where they actually create repeated patterns in one direction. Now we move on to the last type of symmetric patterns, the wallpaper pattern. This is like the freeze pattern where it uses translation, symmetry as a base to indefinitely form repeating motifs in one direction. Except wallpaper pattern uses translation symmetry in more than one direction to cover the whole plane. As you can see from the example, this is one of the example here that shows wallpaper pattern that covers the whole plane. In this case, the isometries contained in it contains translation and fourfold rotations. Now, in case you are confused about the fourfold rotations, let's use this as an example. Remember when I mentioned that about at one point of the axis turn? Well, here's what it is. This indicates identical objects appearing after rotating at a certain axis, where you stop at this certain axis, another stop at this certain axis, and create a full 360, which will create three identical objects. And thus, we call this one a threefold rotation. So in this case, in case you can actually identify it, then you can at least use this as a center where you can see four wings, and that forms a fourfold rotation. As for the second picture, this contains a translation and twofold rotations. In this case, the twofold rotations is actually indicating this one, this pattern. Think of it as this flower where it actually rotate at some point. This rotated at a 180 degrees here and here. Since it's a twofold rotation, it only contains two turns only at two axis point. So that's all there is to it for the symmetric patterns. I hope you learned something, and that's all. Thank you.